Section 12.3 is about counting the number of outcomes, and the first part of 12.3 is about outcomes that occur in a very specific order. Those are called permutations. So if you were in class right now, I would ask you to choose your first, second, and third favorite song of the top 5 most watched YouTube songs. And then we'd talk to each other about what our choices were. And the mathematical question that brings up is, how many ways could someone answer this question? So someone could say that my favorite song is Despacito, and then I like Shape of You, and then I like Baby Shark Dance. Or they could say I like Baby Shark Dance best, and then Shape of You, and then Despacito, and that would be a different answer. So keeping track of how many ways could somebody answer with their first and second favorite song. And so one way we could look at this question is we could say, well, for their first choice song, there are 5 options. They could choose 5 different songs that could be first place. And then for their second place option, because they can't choose the same song as their second favorite, there would only be 4 ways to choose their second favorite song. So there would be 20 different ways that you could list your first and second favorite song. So our first example is we're looking at this pizza menu and we're asking how many one-topping pizzas can we make. So the first thing we have to do is we have to choose a size. We could choose to make a large pizza or a medium pizza. And then we have to choose, so this is the size of our pizza, and we had 2 choices for that. And then we have to choose a crust. We can choose deep or thin. And if we chose a large, we can choose either deep or thin. And if we chose a medium, we could choose either deep or thin for that pizza. So the crust has 2 different options as well. And then once we've chosen the size and the crust, we have to choose the topping. There are 3 choices for toppings. There's sausage, pepperoni, and cheese. And you can see that each of the choices we make along the way, because we have so many options, we wind up having to make that decision about all of these different possibilities. And there were 3 toppings. So one way we could count how many one-topping pizzas we could make is we could just count the ends of our branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 ways. The faster way, because we noticed that the branches, like it goes from 2 branches to 4 branches to 3 branches off of that, is we could multiply 2 different sizes times 2 different crusts times 3 different toppings. And that gives us 12 options. This is called the fundamental counting principle. When there are m outcomes for one event and n outcomes for another event, then to get the number of outcomes for both events to get happening, you multiply m times n. So I'm going to give you a chance to pause the video and give this one a try. For a Happy Meal, you can order a main dish of either a cheeseburger, a 4-piece chicken nuggets, or a 6-piece chicken nuggets. You can choose a side of either French fries or applesauce, apple slices, and you can choose a drink of milk, chocolate milk, water, or apple juice. How many different meals can you make? Go ahead and pause the video and try this problem. Pause now. Since there were 3 different main dishes, 2 different sides, and 4 different drinks, there would be 24 different meals altogether. We could also solve this problem by drawing a tree like I did for the previous problem, but that gets tedious, especially as you get more options. Okay, this section we're going to really focus on permutations. Permutation is when you select some items from a set of items and the order matters. So one way you can tell that the order matters is if you are ranking things. So I'm choosing 3 songs and I'm going to call them my first favorite, second favorite, and third favorite. That's an indication that the order matters. Or if you're assigning different jobs, that's another indication that the order matters. If I were choosing people to be president and vice president, then choosing one person to be president and another person to be vice president and flip-flopping it is 2 different choices. So that in that case, the order does matter. Another definition that you need for this chapter is called factorial. Factorial is indicated with an exclamation point. So when you see a number with an exclamation point after it, it doesn't mean that number is excited. It means that you're going to take the product of that number and all of the integers below that number. So 4 factorial means 4 times 3 times 2 times 1. We don't include 0 because that would, it's not positive, and also it would mean that all factorial numbers would be 0, so that's no good. 4 factorial, it turns out, is the number of ways that we can arrange 4 items if we're putting them all in order. And one way of thinking about that is if I have 4 items that I need to put in order, then for my very first item, I have 4 choices. But once that item is in place, then I only have 3 choices for the second place. And when I choose a second place item, there's only 1 item left to be my first place item. So that's where that factorial comes from. There is a button on your calculator for factorial. The way you get to it is you hit Math, which is a button on the left side of your calculator, right below the alpha button, which is green. And then when you hit Math, there's a menu that comes up, and along the top of the menu, there's Num, and I don't exactly remember all of them, but one of them is prob, and you're going to choose probability from that option of menus. And then factorial is one of the choices in that menu. We'll work with our calculators in class as well. All right. So this is another permutation example. Gabriella is making a playlist with her 3 favorite songs. How many possible orders are there for the songs? So her playlist, she has 3 favorite songs. She's putting them all in the playlist. We just care how many orders there are for those songs. So this is very similar to what I just did on the factorial page, but for the first item in the playlist, she has the choice of any of the 3 songs. But once she chooses a song to go first, she only has 2 songs that could be second. So she has 2 songs that could be in the second position on her playlist. And by the time she gets to that last position on her playlist, she's used up all of the songs except for 1, so she only has 1 choice. So that would be 6 choices. It's also written as 3 factorial on your calculator. Another example is if you have 5 songs that you're choosing to put in order, but you have 8 songs to choose from. So in this case, this permutation, we have a larger group. We're taking a smaller group out of that larger group and putting them in order. So a notation thing, the notation for this is 8P5. And that means that we have the larger group is 8, and we are choosing to arrange a smaller set. And the P means permutation, so it means that they will be in order. Okay. So one way to solve this problem is if we think about Gabrielle's songs, she's only choosing 5 songs, so she has 5 positions. And for that first position, she has 8 songs that she can choose to play. Once she places that first song down, then she has 7 songs that she could play. and then 6 left, and then 5 left, and then 4 after that. That is a giant number. And actually, I'm going to show you some tricks on your calculator so that you don't have to type all of that in, although it totally works to type that in. The other way to do this problem is we could think about, she has 8 songs that she wants to put in order. So the number of ways she can put 8 things in order would be 8 factorial. But there are 3 songs that she's not using, and there are 3 different orders that she could put. There are 3 factorial different orders that she could put those songs that she's not using. So 8 factorial includes 6 different permutations that we're not actually using. So that would be 8 factorial divided by 3 factorial. Another way to write that would be 8 factorial over 8 minus 5 factorial. She's not actually using those 3 arrangements because she didn't use those songs, so we divide that 8 factorial by that number. I'm actually going to pause and pull up a calculator so that I can show you how you can type this on a calculator. One way we can type this on the calculator, there are several different ways. One way is we could just type 8 times 7 times 6 times 5 times 4, and that would give us 6,720. The other way we could do it is we could do math, there it is, prob, and we can choose the factorial button. So we can do this, we can do 8, and then we do math, prob, and factorial button is the 4th one down. And then we're going to divide that by 3 with the factorial button on it. So we get the same answer that way. The other last way we can do it is we can use on the math menu, we can go to probability, and we can use NPR. But if we're using that option, then we have to type our number first. So we type 8, which is our big group, and then we do math, prob, and choose NPR, and then we choose a 5. We are putting 5 items in order out of 8 items. I do want to warn you that if you type it backwards, if you type 5 probability permutation 8, you would get 0, and I don't think your calculator even gives you a warning that you did something weird. But if you have 5 items and you are trying to arrange 8 of those items, there is no way to do that, so that will give you a 0, so be careful of that. All right, so here's the formula for permutations. We just talked about that, but NPR, you would do n factorial divided by the difference. And I have a couple here for you to try. Pause the video and come back and I'll go through how you would do these problems. So here were my solutions to that example. There are 4 factorial ways to put 4 songs in a playlist if you're using all of them. There are 10 times 9 times 8 times 7 times 6 ways to put 5 songs in a playlist if you're choosing from 10, and that would be 10p5, which is 30,240. All right, thank you so much.